Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NTA exam, PhD exam, SET exam, Jest, TIFR, uh, IIT-Jam exam and other exams related to physical science. Okay, so before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my live free classes and which are going to help you to crack the exams related to physical science. Okay, so this is the 9th part of the series of CSIR NET Physics PYQ of June 2019 paper. Okay. So I'm going to start with first question today. This is the 9th part of the series. Okay. So I'll start with the question first of the day. So the question is the equation of motion. The equation of motion. Meanwhile, just let me check. Am I audible or not? Okay. Then I'll start. Because many times there is a audio issue. The equation of yes, I'm audible. Okay. So the question is the equation of motion of a forced simple harmonic oscillator equation of motion of a forced simple harmonic oscillator is x double dot plus omega square x equal to a cos capital omega t. Okay. Where a is a constant, constant at resonance at resonance at resonance capital omega equal to omega, the amplitude of the oscillation, the amplitude of the amplitude of oscillations at large time large times. Options are, so these are part C questions of CSIR NET Physical Science June 2019. Okay, so the amplitude of oscillation at large times. Options are saturates to a finite value, saturates to a finite value, to a finite value. Option B is increases with time, increases with time as root t. Okay, as root t. Option C is increases linearly with time, increases linearly with time, and option D is increases exponentially with time, increases exponentially, increases exponentially with time. Okay. Okay, the question is the equation of motion of a forced simple harmonic oscillator, which is given x double dot plus m omega square x equal to a cos omega t. Okay, capital omega t, where a is a constant at resonance, omega, capital omega equal to small omega, the amplitude of oscillation at large times. Okay, the amplitude of oscillations at large time. Options are saturates to a finite value, B is increases with times as root 2, or C option is increases linearly with time, and option D is increases exponentially with time. Okay, so I'll solve it now. So given equation of oscillator is, that is a forced simple harmonic oscillator. Okay, the equation is x double dot plus omega square x equal to a cos omega t cos capital omega t. Okay, so this is the equation given. Okay, so now we will find the value of x. Okay. Okay, so we know how to solve it, right? It's so we can write like this: d2 square x plus omega square x equal to a sine omega t. We can write it, it's a second order differential equation, right? So we'll find CF. Okay, complementary function, so that is going to be d square plus omega square equal to 0. That implies uh, d equal to plus minus omega, iota omega. Okay, and so CF is going to be a cos omega t plus b sine omega t. Okay, a cos omega t plus b sine omega t. Now we'll find pi. Pi is going to be 1 upon d square plus omega square, and this a cos capital omega t, right, omega t. So this is going to be 1 upon d square. So we know how to do it, right? So a upon in d square we will write that a d square equal to minus a square will write, right? So this is the a is omega here, so we know this is this. Okay, how to solve, how to find out pi, particular integral, right? So this is going to be minus omega square minus omega square plus omega square. Okay, capital omega square plus small omega square, and this is going to be cos omega t, right? So therefore the value of x is going to be the solution, that is going to be CF plus pi, right? So x is going to be CF, that is a cos omega t plus b sine omega t plus CF is a cos omega t upon minus omega square that is capital omega square, okay, minus omega square plus omega square, right? This is one. Now we'll calculate value of x, okay. So calculating limit capital omega tends to omega, because there's an inside omega equal to omega tends to omega of x, okay. Calculating limit omega tends to omega of x, right, using L'Hospital rule will be used, okay. We know all L'Hospital rule, right? L'Hospital rule, right? L'Hospital rule that we know, right? Suppose we have fx upon gx, right, and this gives the value which is infinite. In that case, what we do is we do f dash x upon g dash x, right? That limit at this limit, okay, and then that value will be, and then we get the finite value, right? So we'll use L'Hospital rule here, okay. So this is x equal to limit omega tends to omega a cos omega t, so here we have to use, right, minus omega square plus omega plus a cos omega t plus b sin omega t, okay. So we'll use the L'Hospital rule here, and we'll find x is proportional to t, okay. So x is proportional to t means the amplitude of oscillation at large time increases linearly with time, okay. That is going to be t, right? So it means the option C is the correct, increases linearly with time, okay. So this increases linearly with time. Good question, okay. Very simple question actually, okay. So we have find value of x, and then we put limit omega tends to omega, right, and we have used L'Hospital rule, and we find x proportional to t, and this means these are proportional, right? So it means that increases linearly with time, okay. So option C is the correct option. Next question, guys. Next question is our next question is question 2. These are all part C questions, okay. Part B is already completed in the series, and this is the 9th part of the series, guys. And this is also a good question. It's matrix question, okay. The operator A has a matrix representation so there's an operator and whose matrix representation is given 2 1 1 2, okay. This is the matrix representation of the operator, okay. In the basis spanned by 1 0 and 0 1, okay. 1 0 and 1 0 and 0 1, 1 0 and 0 1. In another basis, in another basis spanned by spanned by 1 upon root 2 1 1 and 1 upon root 2 1 minus 1 1 minus 1. Okay, in another basis spanned by 1 upon root 2 1 1 and 1 upon root 2 1 minus 1. The matrix represent in this basis. Okay, the matrix representation, the matrix representation of A, matrix representation of A is, okay, so the options are, so in another basis spanned by these, right, spanned by 1 upon root 2 1 1 and 1 upon root 2 1 minus 1, the matrix representation of A is, okay, so you need to find matrix representation of A. A is, options are 2 0 0 2, okay, option B is 3 0 0 1, 3 0 0 1, option C is 3 1 0 1, 3 1 0 1, option B is 3 0 3 0 1 1. Okay, okay, so this is the question, guys. Good question. It's a matrix question, so I'll solve now. So we have been given the matrix representation of operator in the basis 1 0 and 0 1, and another basis spanned by 1 by root 2 1 1 and 1 by root 2 1 minus 1. The matrix representation of it we need to find. Okay, so first, because here in this matrix, right, in another basis, the basis the spanned by, okay, the another basis matrix, okay, another is, wait, yeah, in another basis it is spanned by 1 upon root 2 1 1 and 1 upon root 2 1 minus 1, right? So solution is, okay, so in another basis, this another basis, right, 1 upon root 2 1 1 and 1 upon root 2 1 minus 1. Okay, these are the eigenvectors of the operator. Okay, are eigenvectors of the operator, of the operator of the operator of the operator A. Okay, this and this are eigenvectors of the operator A. Okay, so these are the eigenvectors. Okay, these, like in another basis spanned by this, means these are the eigen vectors of the matrix of the operator A. Okay, or we can say eigenvectors of the matrix representation of the operator A. Okay, well, so now the matrix representation of A. Okay, this is very important point which you need to know. Matrix representation of operator A in this basis. Okay, in this basis is going to be diagonal matrix and diagonal matrix. Okay, right? Diagonal matrix, and the main diagonals, okay, main diagonals will be the eigenvalues of the matrix A, okay, because we have been already given matrix A representation, matrix representation of operator A in the basis spanned by 1 0 and 0 1, right? This is given, A is given, A is given, this A is given, A is given 2 1 1 2, okay. Okay, so okay, so this one, so in this basis spanned by these eigenvectors, right? The matrix representation of A is going to be diagonal matrix, and that matrix is consisting of eigenvalues of matrix this A, okay, and A and which are on main diagonal, okay. So so first we'll find, I can write as well, okay, then I will find the eigenvalues. This will be good. So in this basis, matrix A is represented by, in this basis, okay, I'm writing as well so that it will clear your doubt. In this basis, matrix A, in this basis, matrix A is represented by, is represented by, matrix A is represented by diagonal matrix D, diagonal matrix D, consisting of eigenvalues of A, this matrix, okay, which is given, of A on the main diagonal, okay, on the main diagonal, on the main diagonal, okay. So very important point, okay, this is. So in this basis, matrix A is represented by diagonal matrix D, okay. Diagonal matrix D means all the elements except the diagonal elements will be 0, right? We know the definition of diagonal matrix, okay. Consisting of eigenvalues of this on the main diagonal, okay. That is in main diagonal, okay. So we'll find the eigenvalues of this, okay. So how? Here, since A is 2 1 2, okay, A is 2 1 1 2, A is 2 1 1 2, right? And we know how to find the eigenvalues of this, right? This is going to be matrix A minus lambda I is going to be 0, and we know this, right? So this is going to be 2 1 1 2 minus lambda I 1 0 0 1, okay, equal to 0. So we know 2 minus lambda 1, and this is 1 2 minus lambda 1 is going to be 0. We'll solve it further. So it is going to be 2 minus lambda whole square minus 1 equal to 0. So 2 minus lambda is going to be plus minus 1. That implies lambda is going to be 1 and 3, okay, or we can write 3 and 1, same thing, 3 and 1. So according to this, in this basis, the matrix A is represented by the diagonal matrix consisting of eigenvalues of A in the main diagonal, right? So the required matrix is going to be okay, required matrix is going to be, that is D, is going to be, these are the diagonal element, right? 0, 0, 1, 3, 0, 1, 0. This is the answer, okay? 3, 0, 1, 0. So which option is matching, guys? Let me check which option is matching. 3, 1, 0, 1. 3, 1, 0, 1. So option B is matching. 3, 0, 1, 0. Option B is matching. 3, 0, 1, 0. 3, 0, 1, 0. Okay. Okay, guys. So next question. This is question 2, question number 3. Question number 3 is the operator x. This is also very good question and very simple question, guys. Okay, and this is of 5 marks question. D over x, d over dx, delta x, dx, d over dx, delta x, where delta x is Dirac delta function. X is the Dirac delta function. Dirac delta function. Dirac delta function acts on this operator. Okay, x d over dx delta x. Okay, acts on the space of the space of real valued square integrable function on the real line. This operator is equivalent to, okay, this operator is equivalent to options are number A minus del x, number B del x, okay, option C is x, and option D is 0. D is 0, okay. Okay, so I'll read the question for you. The operator x d over dx delta x, where delta x is the Dirac delta function, okay, acts on the space. Okay, this is acting on the space of real valued square integrable function. Okay, so whose values are square integrable. Okay, whose values are real and square integrable functions on the real line. Okay, this operator is equivalent to. Okay, so you need to find out, this is the operator where delta x is the Dirac delta function, acts on the space of real valued square integrable functions. Okay, on the real line, this operator is equivalent to. Okay, so this is very good question. So we know the Dirac delta property, guys. Here is a Dirac delta property we know, and you know, if you don't know, then you need to know, that is x del x dash x del dash x, or x del prime x, is this one, x del prime x plus del x equal to 0. Very important property, guys. Okay, this. from here x, from here x del prime x or del dash x is going to be minus delta x. Okay, from this minus delta x, so we can write Lx, this is d upon dx delta x, right, is going to be minus delta x. Okay, so the value is this very simple question if you know this property. Okay, so which option is matching? Option number A is matching. Option number A is matching, right? So this is just a simple property, right? You should know this one. X del prime x del prime del dash x or del prime x plus del x is equal to 0. Dirac delta property. Okay, from here we can get this. Simple, right? Okay, so this is the answer, this formula, and very see it's you can solve this question in less than 1 minute, right? And this question is of 5th marks if you know this property of Dirac delta function, right? Very easy question. This is the question. Next question, guys. Okay, next question is also a good question related to random walk. Okay, question number 4. Question number 4. This is at each time step, at each time step, at each time step, at each time step, a random walker, a random walker in one dimension, in one dimension, random walker in one dimension, random walker in one dimension remains at the same point, remains at the same point, remains at the same point, remains at the same point with probability, with probability, with probability 1/4, okay, or moves by a distance delta, or moves by a distance, moves by a distance, moves by a distance, moves by a distance delta to the right, to the right, or left, or left, or the left with probabilities, with probabilities, with probabilities 3/8. Okay, 3/8 each. Okay, 3/8 each. After n steps, after n times, after n times, after n time, after n time steps or n steps, n time steps or n steps, after n time steps, or after n steps, its root mean square displacement is, its root mean, its root mean its root mean squared displacement is. Root mean squared displacement is. Root mean squared displacement is. Okay. Options are delta root n. Option B is delta. Option B is delta 9n upon 16. Option C is delta root 3n upon 4. Option D is delta root 3n upon 8. Okay, so this is the question. Very good question, guys. So question is, at each time step, a random walker, so there is a random walker in one dimension, which is in one dimension, remains at the same point with so at each time step, the random walker, which is in one dimension, okay, remains at the same point. If it is at same point, remains at same point with probability. The probability of remaining that walker at the same point is 1/4 given, or moves by a distance delta. So, or either it moves by a distance delta to the left or right, or it may move left or right with probabilities 3/8 each. Okay, so either if it walks right, the probability is 3/8, or either it moves left, the probability is 3/8. That is given. Okay, after n steps, it's a root mean square displacement you need to find out. Okay, very good question. Okay, so I'll solve it now. Okay, so from this question, it is evident, right? From the questions and options, it is evident. Okay, like for this problem. Okay, so you can see from the question and the options, you can see that the XRMS, right? The root mean squared displacement is of the form XRMS is of the form K root n. Okay, it is in this form, because here you can see delta n delta is any value, right? Delta n root n, right? This is capital N root n. Okay, so you can see any constant root n, right? So this is also constant, this is also constant, so this is also in the form K root n, right? Similarly, this is K root n, right? This is constant, right? K, this is constant, so K root n. So the RMS is in the form of XRMS, that is root mean square displacement. Okay, root mean square displacement, that is root mean square displacement is in the form K root n. Okay, that's we can see from questions and from question and options. Okay, now so we'll take special case. Okay, we'll take special case. If n equal to 1, we're just taking special case and then we'll find the answer. Okay, if n equal to 1, special case. Okay, special case. If n is 1, just we have supposed, okay, that if n is 1, so in that case outcomes will be 1, 0 or -1, right? 1 is going right, 0 is remaining at the same point if we take n equal to 1 step. Okay, so for n equal to 1, either for that step that walker will be at the same point, or it will be left, or it will be in right. So there are three possibilities: 1 0 minus 1 times delta. Okay, so they will be delta because uh, step length is delta, right, times delta. Okay, of course, and with probability with probability with probability for 1 it will be, that is right, 3 by 8, and for 0 it will be 1 by 4 given, and for left it will be 3 by 8, right. So we have taken a special case, right, because RMS is in this form, special case. So for first step, either that a person, that walker will remain at the same point, or it will go left or right. So and delta is the length of each step, right. Or width of each step, right. So this is going to be either 1 0 or minus 1 or delta, or we can say delta 0 or minus delta with probability this. Okay, okay, so now we'll find, that is expectation value of x square, right. So that is every average of x square, and we know that formula, right, very important. This is sigma pi xi square. Okay, note down, this is important. Okay, sigma pi xi square, right. Pi is given, these are p1, these are p1, p2, p3, right. Pi is given, these are probabilities, right. So expectation value of x square, or average of x square, is going to be, right. So pi, this is sigma p1 x1. So we can write for this case p1 x1 plus p2 x2 plus p3 x3, right. So average of x square, this is square, this is average value of displacement, right, square of displacement. Okay, average value of square of displacement. So this is going to be, for first case, p is 3 by 8, right, this one 3 by 8, and x is delta, right. So delta we're taking, okay, this is going to be delta plus, this is going to be 0, the distance is 0, right. So this is going to be 1 by 4 into 0 plus this is delta, right. Delta is 0, so, and this is going to be 3 by 8 into delta, right. Delta is the distance. Okay, that is x. So x square is going to, for n equal to 1 we are finding. Okay, so this is going to be, this is the 0, and this is going to be 3 by 4 delta, right, if we add it. So it means, or we can write x RMS, this value x RMS is going to be delta x square, this is x square, right, delta square and delta square, this is delta square, guys, right, this formula, right, xi square. So x I1 square, x2 square, and x3 square, right, delta square, right. So this is going to be x RMS, that is root mean square squared of displacement. Okay, root mean square displacement, you can say root mean square displacement, that is going to be del common, and it's going to be 3 by 4, right, 3 by 4 into 1, we can say, right, 3 by 4. Okay, so for n it is going to be, for any steps, the root mean square displacement is going to be delta root 3 by 4 and n equal to 1, right? So this is the answer, guys. Okay. Okay, so this is simple, right? In this form k root n, right? So this delta root 3 by 4 n. Delta, which option is matching? Option C is matching. Option C. This is option C. Okay. Delta root 3 by 4 n. Okay. Well, so this is the question. Okay. So these are the question, guys. Let me check if I can do one more question. We have a time actually. Okay. Question number 5 I'm going to do. Question number 5 is, in the partial wave expansion, partial wave expansion, the differential scattering cross section, the differential scattering cross section, is given by d sigma upon d cos theta equal to mod sigma L 2L plus 1 e to the power iota delta L sin delta L, then EL cos theta, legendary polynomial, right? Cos theta mod square. Okay, so this is the differential cross section is given, differential scattering cross section. Okay, this is the one, this is given, where theta is the scattering angle, is the scattering angle for a certain Newton scattering. Okay, for a certain Newton scattering, certain Newton scattering, Newton nucleus scattering, sorry, my apology, Newton nucleus. Newton nucleus scattering nucleus scattering. It is found that, very good question guys, okay, it is found that the, the two lowest phase the two lowest the two lowest okay, the two lowest phase shifts lowest phase shifts phase shifts okay, phase shifts delta 0 and delta 1 corresponding to corresponding to S wave and P wave, S wave and P wave, S wave and P wave respectively, okay. Satisfy delta 1 almost equal to delta naught by 2, okay, delta naught by 2, assuming that the other phase shifts the other phase shifts other phase shifts are negligibly small, negligibly small. The differential cross section differential cross section reaches its minimum for cos theta equal to, okay, options are given. Option A is 0, option B is plus minus 1, option C is minus 2 by 3 cos square delta 1, and option D is 1 by 3 cos square delta 1. Okay, so very good question and lengthy question. Okay, so question is, in the partial wave expansion, okay, the differential scattering cross section is given, okay, this is given, where theta is the scattering angle, and for a certain neutron nucleus scattering, okay, for certain neutron nucleus scattering, it is found that the two lowest phase shifts which are delta 0 and delta 1 corresponding to S wave and P wave, okay, respectively satisfy delta 1 equal to delta naught by 2. Okay, assuming that the other phase shifts are negligibly small, the differential cross section reaches its minimum for cos theta equal to, okay. So that's you need to find out. Minimum means you will find the differentiation of that differential cross section scattering, and you will make that equal to 0, and you will find the value of cos theta for the minimum value, right? Okay. Okay, so I'm going to solve now. So we have been given, so here we know, okay, we know, I'll solve here, okay, we know the d theta, right? D theta is simple differential coefficient, differential cross section, right? Differential scattering cross section, okay, or differential scattering cross section, right? Which is the function of theta. We know which is given, right? So this formula is, you know, that is sigma L 2L plus 1, okay, e to the power iota delta L sine delta L PL cos theta, right? E to the power I delta L sine delta L and L cos theta, right? So this is the formula for differential scattering cross section, okay, so which is also given here. So now what we'll do is we'll solve it, and then we'll do d theta upon d theta equal to 0, and we'll find the value of minimum value for cos theta, right? Value of cos theta for minimum, okay. That is the differential cross section reaches its minimum for what value of cos theta, that we'll find, okay. Well, so now because it is given, right, so this is so we have to ignore the higher other wave shifts, right? They are negligibly small, higher wave shifts, okay. Only will consider delta 0 and delta 1, okay. Okay, so for L equal to 0 and 1, right, so there, so that we can say L1 equal to 0 comma 1 and L2 equal to 0 comma 1, okay, for L equal to 0 1, right. So now this D, the differential cross section, is going to be d theta, that is D, which is function of theta, is going to be sigma L L1, okay, sigma L1 to L1 plus 1 e to the power iota delta L1 sine delta L1 delta L1, okay, PL1 cos theta, okay, this is one, and another is going to be sigma L2 to L2 plus 1, okay, e to the power iota minus iota, okay, this will be minus iota L2 minus iota L2 minus iota L2 sine delta L2 P2 cos theta. Okay, very important step, guys. Okay, L2, right? This is one because we have been given this, right? Differential cross section. This one. Okay, so this is going to be this, d theta is going to be this. Okay, very important formula you have to know. Okay, this is, we can write like this given differential coefficient or differential scattering cross section like this. Okay, so we have taken L1, so we'll take L1 equal to 0 1 and L2 equal to 0 1. Okay, so this is the formula, guys. Okay, well, now we will put L1 equal to 0 1 and L2 equal to 0 1 in this expression. Okay, so first we'll put that is L1 equal to 0. First we'll put 0 0, L1 L2 0, then L1 L2 1 1, then L1 L2 0 1, then L1 L2 1 0. Okay, so this is going to be d theta. This is going to be like this one, right? This I'll explain it. So first what we are going to do, we are putting L1 equal to 0 and L2 equal to 0, right? Then we'll put L1 equal to 1, L2 equal to 1. Then we will put L1 equal to 0, L2 equal to 1. Then we will put L1 equal to 1, L2 equal to 0. Okay, so if you put L1 equal to 0, so it is going to be, this term is going to be 0, this is 1, this is e to the power delta 0 sine delta 0 p cos 0 p0 cos theta, right? This is legendary polynomial and the value of this is 1, right? Similarly, we will put L equal to 0 here and then 1, right? Then 0 1 and then 1 0. Okay, so I'm writing it now. So it is going to be e to the power iota L equal to 0 for L equal to 0. Okay, e to the power iota into del 0 sine delta 0 and p0 cos theta. This is the first term for this one, right? L equal to 0. Now L2 equal to 0 we will put. So this expression is going to be e to the power iota del 0 minus iota. Okay, del 0, then sine because this is the value, right? This is in mod square and this value is this. Okay, so this is going to be sine theta del 0 p0 cos theta. Okay, p0 cos theta. p0 cos theta. Okay, next L equal to 1 will put. So this is going to be for L equal to 1 here. 1 means 2 into 1, 1 plus 2 into 1, 2, 2 plus 1, 3, right? This is going to be 3 e to the power 3 e to the power iota delta 1 L equal to 1. Okay, sine delta 1 then p equal to 1 p1 cos theta, right? This is one term and the second term is going to be L equal to 1. So this is also going to be 3 e to the power minus iota delta 1 sine delta 1 p1 cos theta. Okay, Next term, L equal to 0 and L1 equal to 0, L2 equal to 1. Okay, so this is going to be e to the power 0, right? E to the power iota delta 0. Very important step, guys. Okay, iota 0 into iota delta 0 into sine delta 0 p0 cos theta. Okay, here L equal to 1, so it is e to the power minus iota delta 1 sine delta 1 p1 cos theta plus, and this is going to be 3 e to the power iota delta 1 sine, now L equal to 1, L1 equal to 1 and L2 equal to 0. Okay, so this is sine delta 1 p1 cos theta, okay, and this is e to the power minus iota delta 0, right, sine delta 0 p0 cos theta, right, guys? So what we have done, first in first term we have put L equal to 0, L1 equal to 0, L2 equal to 0. In second, L1 equal to 1, L2 equal to 1. In third, L1 equal to 0, L2 equal to 1. In fourth, L1 equal to 1, L2 equal to 0. So we've got 1, 2, 3, 4 terms, right? We'll solve it now. So d theta is going to be, so we solve it, right? So this is going to e to the power iota delta 0, e to the power minus iota delta 0. This is 1, going to be 1, right? We multiply. So this is sine square delta naught, and this p1 cos theta and p1 cos theta. This value is 1, guys. Okay, I'll write it. Legendary polynomial. Okay, p0 cos theta. This value is 1. Okay, and second, p1 cos theta, this value is cos theta 1 upon 2 cos theta. Okay, is 1 upon 2 theta. Okay, very important, legendary polynomial value. Okay, so now we'll solve it. So this is going to be sine square delta 0 delta naught and this solving. Okay, so plus 9 sine square delta 0 by 2 cos square theta, right, because this value will be cos theta by 2 cos theta by 2. This is cos theta, guys, sorry, this is cos theta, p1 cos theta equal to cos theta. Okay, this one, and cos square theta plus 3 by 2 sine square delta 0, then cos theta. Okay, we're solving. So this is going to be e to the power iota delta naught e to the power minus iota delta 1. Okay, plus e to the power iota delta 1 into e to the power minus iota delta naught. Okay, this one. And here also we have put this, okay, because in question this is given delta 1 equal to almost equal to delta naught by 2, so we have put this value as well. Okay, now we will put it this value. Okay, so this is going to be d theta is going to be, if you put the value, so it is sine square delta 0 plus 9 sine square delta 1 cos square theta. Okay, we have put the value. Okay, plus 3 sine delta naught sine delta 1 p1 cos theta and this is going to be e to the power iota delta naught e to the power minus iota delta 1 plus e to the power iota delta 1 e to the power minus iota delta naught. Okay, so now we'll find, this is the value of differential scattering cross section. Okay, so now for minimum value what we are going to do is, here we can put this value. Okay, delta 1, so this is going to be like the delta 1 value, we put it. Okay, so this is going to be 9 sine square delta 1 value is going to be delta by 2 delta naught by 2. Okay, here this value is going to be 3 by 2 sine square 3 by 2 sine square cos theta into this value. Okay, right here. Okay, wait guys, my system got hanged. Just wait. Okay, so this is going to be e to the power iota e to the power iota delta naught e to the power minus iota delta 1 plus e to the power iota delta 1 e to the power minus iota delta naught, right? So now for minimum value of cos theta, what we'll do, d upon d theta will differentiate with respect to theta. Okay, and if we differentiate it, then we'll differentiate with respect to theta and we'll make it this expression equal to 0. And after solving, what we are going to get, sine theta equal to 0 and cos theta value is going to be minus 2 by 3 cos square delta 1. Then the question. Okay, this is the answer. So cos theta value is for minimum value. We'll differentiate this with respect to theta, and that will make it equal to 0, and then we'll get the value of cos theta. Okay, so this is minus 2 by 3 cos square delta 1, minus 2 by 3 cos square delta 1. Okay, so which option is matching, guys? This is lengthy question. You need to practice this, guys. Okay, practice it and revise it. Then it will be clear to you. Okay, so which option is matching? Option number C is the correct option. Minus 2 by 3 cos square delta 1. Option C. Option C. Okay, yeah, minus 2 by 3 cos square delta 1. Well guys, so before ending the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. Okay, so okay guys, thank you so much. Bye now.